Lesson 25, Triangle Congruence, SSS. SSS. SSS stands for side, side, side. So if you have two triangles whose corresponding sides are congruent, then their triangles will be congruent. Okay. So I don't know. Oh, we go over corresponding real quick first. So if we have triangle ABC and triangle XYZ, if we can say that triangle ABC is similar to triangle XYZ, so if we're told that, when they're similar, the angles will be congruent, but the sides won't necessarily be congruent. They will be, the sides will be proportional. Yes.
What does that little symbol mean that's between?
Oh, this is similar to.
Is that its name or is it like?
Oh, it's a tilde. It's, yeah, it's called a tilde, but it's just, it means in math similar to. Say what?
Doesn't it also mean not?
Not. Yeah, we use it for not.
Similar
That's
and
true.
not.
Similar to and not?
Whoa,
Oh,
but that's a
that's like-
totally different context. It's weird that I've never even
Whoa.
noticed that.
That's weird. They're so like opposite.
Okay.
They're pretty much opposite. I'm gonna get you
Oh, then we better use
it's
something different for not, because this is always similar. Okay, so angle A and angle X are corresponding. You can look at the figure and see it. For me, the best way is to look at the names. So the first letters are the angles that are corresponding. The second letters will be corresponding. And the third letters will be corresponding. So when you are writing that two triangles are similar or that they're congruent, you have to get them in the right order, because it has to be the angles that are corresponding have to be in the same order on both triangles. Yes.
Okay, so
Benjamin.
I'm probably mathematically incorrect, but sometimes I do like my triangles in different orders.
Oh.
Are you supposed to do it in the exact same order every time?
No, wait, no. Like, you could name this BCA, CAB, that's okay. It's when you are putting it similar to another triangle, then the order matters.
Oh, okay.
Okay, so it's okay to, if you just have a single triangle. And then for the sides, it's the same, the order of the letters. So the first two letters would be a side that corresponds to the first two letters, that side in the other triangle. So then, say the last two, so side BC will correspond to YZ, and then the first and the last, AC, that's the third one, will correspond to XZ. Yes, Rebecca?
So you couldn't go ABYX.
No.
Okay.
Weird, huh? Yeah, it has, so the order matters when you're naming how they're corresponding. You have to have it in the same, even this way, you have to have it that way.
Could you go BAYX?
Yes, you could.
Just not the other way. Not one the other way.
One the other way, and yeah, they have to be in the right order. Yeah, so you could do BAYX or ABXY. Those are correct, but you couldn't do ABY.
At the same point.
Right, the same.
So
Yes, like the same angle that they correspond with. So if you start with A, you're going to start with X, basically. Okay. Now, if all corresponding sides and angles are congruent. So that just means that A is congruent to X, B is congruent to Y, C is congruent to Z. Like, these are congruent. Not necessarily with each other, just the corresponding ones are congruent. Then the figures are congruent. And that's for any geometric figure. And we're gonna just focus on triangles today. Yes.
So, is that considered a theorem or postulate, or is that just
Yes,
common
it's
sense?
the, let me see, they call it, it's a postulate. It's Sss Congruence Postulate. Side, Congruence Postulate.
Okay.
In fact, let's put that Sss Congruence Postulate. And yes, we will be using this in our proofs. In fact, we'll use it a whole lot. Like, whole lot. Probably because it's the first one we learned. So, we're going to draw two triangles that form like a giant, this thingy. I don't know what you call that.
Hourglass thing?
Yeah, like an hourglass thing. We're going to say that these two lines are parallel. Here, we're going to call this A, B, C, D, E. So I went around instead of, so A, B, C, D, E. Okay. So when we look at this, we can see that because these are parallel, angle A and angle D will be congruent by the alternate interior angles theorem. And then angle C will be congruent to angle E by the same theorem. And then CBD will be congruent to ABE by the vertical angles theorem. So we could say that triangle ABE will be similar to triangle. So if I started at the A that has one arc mark and I went up to the middle, I'm going to start at D and go up to B and over to C. So DBC. So if you look at the angles and see which ones it's congruent to, then you can get the right order. So those two will be congruent. I'm not going to write this down because we already did. Sss Congruence. Triangle rigidity. Rigidity. I feel like it is like the name, rigid. It can't be moved. And this just means that one triangle can be formed with three fixed lengths. So if you're given three lengths that make a triangle, you can only make one triangle out of it. You can't make multiple triangles with, oh, that's lengths, three fixed lengths. This, you're gonna maybe want to laugh, but don't. CPCTC stands for, so we can use this in our proofs. The problem is knowing when to use it. So I'm going to try to teach you, and we'll be using it a lot. So I'll try to help you as we go through our problems. CPCTC means corresponding parts of congruent triangles are congruent. So what's that saying is, if you know the triangles are congruent, then you can say all of their corresponding parts will be congruent. Andrew.
So to make two triangles, you basically need 4 lines.
3. Oh, 2. Wait, what?
Because, well, on the diagram it only has 4 lines. Or a CB 4 line.
Oh, CB is a segment in this triangle.
Well, so could it be CE that makes, so to make 2 triangles you do CD, AE, CE, and then AE.
Oh. If they're set up this way where they're sharing a vertex, that's how you could do it. Yeah. You can even share a side, and then that would still be that would be 5 though, okay. All right, we're gonna draw two triangles oriented slightly differently so that we can talk about this CPCTC. So RN is going to correspond with L. Oh wait, I'm going to write the congruent statement first. Okay. So triangle run is congruent to triangle LTO. So RN is congruent to LO. Angle R and L will be congruent to each other. Angle U and T will be congruent to each other. And NO spells no. Those are congruent to each other. And then RU and LT, those sides will be congruent. And then UN and TO. So you can write, this is called a triangle congruent statement. And then you can write the 6 congruent statements for corresponding parts. So you could say angle R is congruent to angle L, angle U is congruent to angle T, angle N is congruent to angle O, segment RU is congruent to segment LT, segment UN is congruent to segment TO, and segment RN is congruent to segment LO. So these are the 6 congruent corresponding part statements, and this is called a triangle congruent statement. And you'll be asked to give a triangle congruent statement, and you want to make sure you're doing it this way, because that won't be correct. Shoot. Okay, we'll end the lesson there. That's the end.